Swayam Prabha. Digital India. Educated India.
Good morning everyone, my name is Gangesh Agarwal and I'm from class 11 IBDP.
And I'm Prakash Siddha. I'm from class 11 IBDP and we're from Scottish International School.
And today we are going to present our skit to explain thermodynamics through the use of a car radiator.
Wakanda forever.
Hey, my man is still stuck in the Marvel phase, huh?
Yeah, I just watched Wakanda Forever yesterday.
Again, it's such a long movie.
It's a very good movie.
But it's too long, it's so slow.
It's still very good. It has good character narration.
You know what? Agree to disagree. So, what's up?
Nothing. What about you?
Oh, I'm just looking at my college application. You see, there, while I'm applying for my course, since it's mechanical engineering, so they want me to give an idea, like a theoretical idea, so that they know that I'm actually capable of doing the course.
So why don't you give them something about sustainable cars, like those tiny cars that are self-sustaining and they work on their own?
You know what?
Yeah.
I was just thinking along those lines.
Oh,
you know, like a car that should be able to work on its own. You don't have to keep on giving it more fuel or keep on charging it, and it's durable. You know, didn't you? Wait a second. You had your Tata Nano, right?
Yeah.
3 weeks ago, it had an incident, didn't it? On the
did.
expressway. That's where I got the inspiration for my idea.
Ah, okay, I see. You want to know the full situation that happened with the Tata
Let's just
Nano?
say that you were not responsible with your car.
Bro, I was. I brought it to the Tata service center.
Okay, what happened? Huh?
Right, so basically here's the situation. Mumbai Expressway, I'm driving the Tata Nano and I'm going 80 kilometers per hour.
80 kilometers
Yeah, it's a normal speed, so the engine is already overheating. I can feel it inside the passenger cabin. But then the car randomly breaks down. Right? So I had to call a tow truck from the side of the road. And it took 3 hours for the tow truck to arrive. And once it did, we went to the Tata service center and they took a lot more hours to just analyze what went wrong.
Bro, I told you, change your car. First of all, a Tata Nano at 80 kilometers. On paper, it's written that the optimum maximum speed would be 75 kilometers, but practically it's 70. And now you're driving it on 80. How did you get the extra 5 kilometers per hour?
Modifications.
Modifications.
Yeah, modifications.
Yeah. Let me just tell you how a radiator works. Alright, just look at this. So this is the radiator. Alright, and now here are the fins that you were telling me, which I think broke in your car.
See, here's what broke down. There was the radiator fins that broke, and then coolant valve, like the one that maintains the pressure, that was leaking. So those two combined for a recipe for disaster.
But look at this now. I told you before you went on your trip that you have to fix the fins and the radiator cap because you have the two pipes over here. This is the outlet and this is the inlet. And here is your coolant, which is not water, by the way.
Yeah, it's not water. It's a 50-50 mixture of water and antifreeze. Antifreeze is basically ethylene glycol.
Right. But isn't that a bit toxic for drivers?
See, in some countries, they consider this to be too toxic, and in that countries, they use propylene glycol.
Yeah, but ethyl is more efficient.
Yeah. It's more efficient, but it's more toxic. So there's like this trade-off. Some companies prefer propylene, some companies prefer ethyl.
Your Nano traded off a lot more than just a toxic element.
It's still a good car. It's very reliable.
But just look at this, right? So the coolant, it passes through these pipes over here and it goes towards the engine where it cools down the engine and continuously evaporates as well, right?
So it doesn't exactly evaporate. So what the antifreeze does is that, you know, the engine's already very hot. It's like 120 degrees in there. So because of the mixture of water and ethylene glycol, the boiling point of this solution is almost 130 degrees. Plus you have the pressure cap.
The pressure cap.
Right, so that valve controls the pressure and it's at a higher pressure than ambient. So because of this increased pressure, it's impossible for a gas to form inside this system.
Yeah, but so basically the coolant, then there's a heat diffusion happening, right, over here. At the engine and then at the fins also.
Yeah.
Right, because the coolant is...
before that also there's a step that once it goes through the engine may not be that hot. Then there's this thermostat. If the thermostat detects that the coolant is to
cool.
So then it creates a closed system within where there's no radiator used. It just revolves around here.
Oh yeah, I did read about that. Then you have two closed systems working
Exactly.
in over here. The one is the one, the inside which uses the same heat from the engine to keep on circling the same coolant, and then once the temperature is too high, the thermostat expands, and then it uses this whole fin system
Yeah.
and the fan system to cool down the coolant, and then use it again for the engine.
Exactly. All of this is just to maintain the heat equilibrium inside the engine.
So basically over here, when the coolant is passing through, this fan over here is using the centrifugal force to suck out the heated coolant, and then it passes through fin. So we have heat diffusion happening over because it's passing through all the zigzag pipes, and because the heat is being conducted, so the aluminium fins take away the heat from the coolant, and then
Basically, inside the radiator core, there's like this multiple tubes, like you said,
Yeah, the
zigzag
multiple
lines.
tube.
Like outside each tube, there will be multiple very thin aluminium fins.
yeah, so they take the heat from the coolant.
Exactly.
Right?
So there's like this mesh through which the air
Yeah.
passes through. That's
And
how
because
the
the
heat is
surrounding air,
transferred.
the surrounding air takes away that heat
Yeah.
from the aluminium
Yeah.
fins, and then it cools down the car. So we have that whole other.
And so you know
open
the
system
outlet for
going
this,
on.
like the windshield, in front of the windshield, there's
Yeah,
like this
you have
tiny
those
slot.
tiny little exhaust
Yeah, that's
kind of
where the
drains.
heat releases from.
Yeah. So basically, this whole system, in this closed system, the factors that are only affecting the engine temperature are the coolant, right? There's nothing else that's.
There's the coolant, there's the pressure, there's the engine computer. Oh, by the way, newer cars have replaced the thermostat and everything else that is mechanical with the engine computer. That just uses sensors and electrical values to control everything.
You know what? I think that I have explained how the radiator works, and I
Yeah.
think you need to change your car now. All right.
mean,
Let's just end this topic over here. All right.
All right. I hope you understood what we were trying to explain, and thank you very much.